Today we'll be diving into a custom Polars expression that will take student scores and assign a letter grade based on a curve. In a bell curve grading system, students are assessed based on how they perform compared to other test takers. Now, a lot of people have encountered bell curve grading in school, and the purpose is to create consistency. What do we mean by consistency? Well, let's say that a test in one semester is much more difficult than a test in a different semester. In such a scenario, low test scores are possible even for the quote-unquote smart kids. Giving a grade based on the direct results of a difficult test wouldn't be a fully fair assessment, especially if the test is much easier the next semester. Grading on a curve solves this problem. Using basic statistics, we can easily create a bell curve grading tool in Polars. And now in this example, we are going to be assuming that the curve is a normal distribution. There are other methods of grading that might fit certain data better, but we're going to just keep it very simple here. And let's go ahead and talk through the custom expression that we've created. So it's right here. I'm going to expand this here. And this is going to do all of the bell curve grading behind the scenes. There's not going to be a lot of math that we actually have to do after we create this expression. Let's go ahead and talk through what this custom expression is doing. So at first up here, we are basically calling Polars and registering a new expression namespace. This is what you're going to use when you are working with Polars to call your custom functions. So we're going to call ours stats. We've got that there. And then below that, we're going to define the class. So once again, you can keep it very simple, name it pretty much the same thing. Could be whatever. The thing that you're actually going to be referencing here is this name here. So whatever you call the class doesn't really matter that much, just as long as you know which expression and namespace you're reserving there. Okay, so within the class, we're going to, first of all, use this init function, which is going to basically tell Polars that this is going to be an expression. And so we're going to call PL expression right here, and then we're going to define that variable and then basically introduce this variable here. After you do that, you can go ahead and define your functionality. So in this case, I've created a bell curve function for our stats class, and it's going to require a scores column. So we'll show you how to use this in just a minute. But that scores column is going to be used throughout the function. So we're going to define that. And what it's going to do is look for the mean. So it's basically going to total all of the scores and give the mean. And then it's going to do the same thing for the standard deviation. And what it's doing there is basically setting up the bell curve, trying to figure out where the center is. And then from there, it will create the standard deviations and everything like that. So that's what's going on there. And then just below that, we have the z-scores. And what it's doing here is it's actually going to take each individual record and create a z-score for that record. So it's going to grab all of the scores one by one and assign where that falls on the bell curve. Okay, and then the real magic happens, or magic's already been happening here, but the grading happens right on this next piece here. So we're using a pl.when and then statement. This is basically Polars' version of I guess explicitly typing out like a case when, kind of similar to SQL. But what we're doing here is we're then assigning and figuring out, based on the z-score, what letter grade we should be giving this individual. So you'll see that played out when we actually run this function, but this is where it's actually doing that assignment of what letter grade it deserves based on the data that it's been passed. And then we're going to alias this as grade. So we're basically creating a new column on top of our data frame that will give us the letter grade. So that's the entire custom function that we've created. I know that was a lot. Let's go ahead and just run this function. Okay, so the next step is going to be to load our data into Polars. So let's go ahead and do that. We're going to type data frame, set it equal to pl.read CSV. And I highly recommend using the helpers. They certainly come in handy. Okay, and then I need to navigate to our data set and just need to get the path right here so we are pulling it in correctly. Okay. So I didn't get a lot of help on getting that path put in there, but this is correct. It should work now. Let's go ahead and run this and look at our data. Okay, and in the output, you can see that we have this data set here that has the student name and their test score. So you can see we've got a variety of scores here. Obviously, some are doing better than others on this test. Okay, so now that we have our data, let's go ahead and do the next step, which is use our function. So I'm going to scroll down just a little bit here, and we're going to click into this cell. And once again, we're going to basically redefine our data frame. We're going to type df.withColumns, and then we're going to select our column by saying pl.call, and then make sure you get the name right, so it's score there. You might have different data that you might be using this on. And then from here, we can actually call our new expression. So we can type .stats, which is what we defined up here. It's this one right here, not the capital S. That won't work. So we have the namespace created there. We're going to call our bell curve function. And I wish it would give some helpers. I don't know if maybe I just haven't refreshed it and it's not showing up. This is a function. It does work. So we're just going to type now. The one parameter that we need to pass is the score column. So let's go ahead and type score. And then I do want to display the results of the data frame. So I'm going to just type df and then go ahead and run the cell. Okay, and in the output, you now see that we have a new column which has our letter grade. And you can see some are doing, again, better than others. On a typical grading scale, an 89.9 would probably be considered a B, B plus, or however the scale is there. It would not generally be considered an A, but it's basically bumped that up to be an A because there's some that have done worse, obviously, on the test. So it's adjusted to the average, and it's basically reassigned the grades. Okay, I hope you enjoyed this video. If nothing else, it really demonstrates the power of these custom expressions that you can do within Polars. This was just one specific application, but Polars does have some amazing capabilities to allow you to create these custom namespaces, and these different expressions and functions to integrate it into the library. It's really nice. I highly recommend checking it out. You can see that on the Polars documentation. There is a section on there that allows you to look at basically customizing and doing all this stuff. So with that said, I hope you enjoyed the video, and we'll catch up with you at the next one.